Hello everyone, welcome to my YouTube channel. Myself Hardik Shetty, currently pursuing in second year in Sri Venkateswara College of Engineering, Vidyanagar, Bengaluru. Today we are going to discuss about a research paper which holds the title of header using different design styles. As we know, the research paper title is Off Header Using Different Design Styles. It was published in the Journal of Advancements in Robotics in Volume 7 and Issue 3. The authors are Anju Rajput, Triti Dua, Reenu Kumawat, and Aviweni Srinivasulu. The abstract of the research paper is a off-adder is a digital logic circuit that performs addition of two single-bit binary numbers. Generally, in various types of processors, adders are used to perform arithmetical and logical operations. Working of off-adder is analyzed by designing it by using three different logic styles, that is CMOS logic, transmission gate logic, and pass transistor logic. The comparison has been made between the circuits on the basis of their power consumption and transistor count. Simulation of the circuits is carried out using HSPICE tool at 45 nanometer, 32 nanometer and 16 nanometer technologies at 1 volt power supply. After simulation, it is observed that power consumption is lowest when the adder is implemented by transmission gates as compared to CMOS and PTL design styles, whereas transistor count is minimum in case of PTL design style. It is also inferred that CMOS gives the best performance out of the three design styles. The next topic is introduction. In recent years, there have been many developments in the field of portable equipment in which batteries plays the major role. With increase in the design complexity, the power requirements of such devices also get increased. So in order to combat these requirements, it becomes necessary to investigate the new techniques to design low power, high performance and reduced area circuits. Nowadays, there are different logic styles available to design any circuits. Adder circuits are of two types, off-adder and full-adder. In this paper, off-adder circuit is realized using three different logic styles, that is transmission gate, pass transistor and CMOS logic with three different technologies. Their analysis is done to obtain minimum power dissipation as well as they compared in terms of transistor count. The off-adder is a digital combinational circuit that executes addition of two single-bit binary numbers and generates two outputs, that is, a sum bit and a carry bit. If A and B are taken as primary input bits, then sum bit is obtained by XORing of input bits A and B, and the carry bit is obtained by ANDing of input bits A and B. Off-adder is the simplest adder circuit and used in many applications such as to design full adders and calculators. In ALU of various processors to calculate the address and many more. The Boolean expression of off-adder is given by sum is equals to A exclusive or B and carry is equals to A into B. The block diagram and logic gate of the off-adder is given, and according to the truth table of off-adder, the sum output is replica of input B when input A is at low logic, whereas it is complement of input B. When input A is at high logic, the carry output is logic 0 when control input is at low logic, and it is same as input B when control input A is at high logic. The next is transmission gate logic based off-adder. Transmission gate is designed by connecting PMOS and NMOS devices together in parallel. Transmission gate is symmetrical from input and output both ends, as input and output terminals can be interchanged. Transmission gate is a digitally controlled switch, as control signal applied at gate terminals of the transistor decides the switching state of the gate. Pass transistor logic designed by NMOS transistors have a disadvantage that it is a weak zero device which is removed by transition gate logic since it utilizes both NMOS and PMOS transistors. the logic gate of the transmission gate is given. When a control signal A is at low logic, then gates P2 and P4 are in cutoff mode and behaves as open switches, whereas transistors P1 and P3 are triggered on and behave as closed switches. Conducting paths are available between data input B and some output and 0 volts and carry output only. Thus, some output is obtained as replica of input B and low logic is obtained at carry output in this case. When control signal A is at high logic, then gates P1 and P3 are in off state and do not conduct, while gates P2 and P4 are in on state and conduct to produce desired outputs. Hence, some output is obtained as complement of data input B and carry output is produced as replica of input B, and the simulation is also represented in waveform, which is given. The next is off adder using pass transistor logic. Pass transistor logic is implemented by NMOS FET. It acts as an electrical switch which passes or blocks the signal which depends on the value of control signal. PTL is used because it requires fewer transistors to implement any logic gate. Primary inputs can be used to drive gate as well as source of NMOS, which leads to reduction in number of transistors and required to implement a logic gate, and the logic gate of pass transistor is also given. In this circuit, primary input A is treated as control input. When control input A is applied as logic 0, then transistor N1 and N3 are switched on and behave like short circuits, whereas transistors N2 and N4 are switched off and behave like open circuits. Thus, input B is passed to the output line representing some S and carry output C is obtained as 0 volt, that is logic 0. When control input A is applied as logic 1, then the transistors N1 and N3 are turned off and behave like open switches, whereas transistors N2 and N4 are turned on and behave like closed switches. Thus, some output S is obtained as complement of data input B and carry output C is obtained as replica of data input B, and the simulation of waveform is also given. Next, off adder using CMOS logic. Complementary metal oxide semiconductor, which is commonly known as CMOS, logic deploys symmetric number of both types of MOS, FETs, that is PMOS and NMOS. This leads to better performance of any logic circuits since NMOS is strong 0 device and PMOS is strong 1 device. Thus, CMOS provides complement 1 and complete 0 logic at the output with any distortion. The logic gate and this simulation of waveform is also given. The next is comparative analysis between three gates. Off adder is implemented using transmission gate logic, pass transistor logic, and CMOS logic. Off adder designed by PTL utilizes minimum number of transistors and thus it is most area efficient out of three design styles. All these circuits are simulated using Synopsys HSPICE tool at 45 nanometer, 32 nanometer and 16 nanometer technologies at 1 volt power supply. Power dissipation consumed by all the circuits are found out and tabulated below. After comparison, it can be inferred that power consumed by the circuits designed using TGL and CMOS design styles is comparable, but the circuit implemented by PTL consumes much higher power and it is represented in the table form, which we can see it. The next is conclusion. Comparison of off adder implemented using pass transistor logic, transmission gate logic, and CMOS logic has been revived on the basis of power consumption and transistor count. The circuits are stimulated using Synopsys HSPICE tool at 45 nanometer, 32 nanometer, and 16 nanometer technologies at 1 volt power supply. It is concluded that circuit designed by PTL is area efficient as it deploys minimum number of transistors as compared to TGL and CMOS design styles. The power consumed by off-adder designed by TGL and CMOS logic is in range of nanowatts, whereas that implemented by PTL consumes power in the range of microwatts. So it can be said that TGL is power efficient design style, but CMOS design style gives best performance out of the three design styles. The next is references of the research paper. The first one is design of area and power efficient off header using transmission gate. The second one is lower power VLSI design using pass transistor logic. The next is design of low power CMOS logic circuits using gate diffusion input technique. The fourth one is delay analysis of off subtractor using CMOS and pass transistor logic. The fifth one is reversible multiplexer and its transistor implementation. The sixth one is implementation of full adder using CMOS logic styles based on double gates. The seventh one is a comparative study of full adder using static CMOS logic style. The eighth one is uh, performance comparison of pass transistor and CMOS logic configuration based on demultiplexers. The next one is uh, design of low power and area efficient off adder using pass transistor and comparison of various performance parameters. The 10th one is full adder designs using low power full swing XOR and XNOR structures. The next one, a low power high speed CNTFETS based full adder cell with overflow detection. The last one is low power and fast full adder by exploring new XOR and XNOR gates. And that's all for video. Please subscribe to my channel for more videos and please like this video. Thank you.